In Section 5 of Module 6, we're going to go over natural logarithms and changing bases. So we'll look at what is a natural log, which is base e, and for some of you at least, I'm sure this is unfamiliar. Then we'll go to a changing base formula, and then we'll do some graphing of base e. Now, to start us off, we're going to take a look at item 1 here of our mini lecture. And natural logarithms are generally referred to using the initials L, N. This is what you'll see on the calculator. Now you might say, how come it's like backwards? Natural log, you would think it would be NL. Well, the reason is that this is from the Latin, Logarithmus naturalis, something like that. So that's the symbol. Now, what I'm going to do is, we haven't done this yet, is to use some of the PowerPoint slides that give you a nice introduction to natural logarithms. So here's the first slide, which is from the PowerPoint series. And we say natural logs are built around the letter E. Now, the letter E has a numerical value. If you looked at your textbook, they give you the derivation of this, but what we usually do is we round this off to 4 decimal places. So we would look at the 5th place, which is an 8. So then this would become a 3 here. And it's approximate because this is an irrational number. That is, it doesn't terminate. And is very useful in mathematics, and we consider it here the natural log. Natural log, letter E, and then to 4 decimal places. Now, most calculators can find both the common log, and we had a little bit of this earlier. Common log is base 10, and the natural log, which is what we're talking about here, is base E. So both of these are found on your calculator. This one is just usually log, capital L-O-G, and the natural log, and I'm looking at my calculator right now, is L-N. So these are keys on your calculator. Common log, base 10. Natural log, base E. Now you may want to take some notes on this. This is the actual change of base formula. Now when we use it, we usually modify it, and what they're saying here is you're going either to log base 10 or base E. You can use either one. And you just take what would be in the answer position, the M, and then divide it by what's in the base position. We'll give you an example on the next page, but let's clear this up so you can physically write this into your notes. This is the change of base formula. And we'll pause. Now, here they're giving us a particular example where it's log base 3 of 7, and we want to find what it is. Well, how do we write it? Well, again, we would go in our calculator, and in fact, if you wanted to write it out, you would just write it out as we did. Make this base 10, and then take the answer, put it there in the numerator, and then the base you put in the denominator. And there's the formula. Now, when you put that in the calculator, if you were just to put this, you would get this. And if you just put the denominator, you would get this. But normally this doesn't appear. What happens is it gives you the answer right away. So this step is internal within your calculator. You don't get to see this. Now we're jumping ahead a little bit to graphs now of exponential and logarithmic functions base E. Now we are asked to graph this, and we'll have some similar ones in our mini lecture. Alright, how do we know this is a graph of base E? Well, because of the E right there. And this we had before. You may remember them. It looked like function of, let's say, 2 to the x power. And the one we had was function 4 to the x power. And we also did function 3 to the x power in an earlier lesson. And as a quick review, this one, 2, was the red line. As it went to 3, that was the blue line. It went closer to your y-axis here. That's a y. And then 4 went there. Now, where is E on here? Well, E, we said, was equal to 2.7183. Well, this one was at 2 here. So this one, when it goes through, is going to be a little higher. And we'll actually see it on the next slide. But we're also interested in seeing what happens when we add 1. And you may recall we said when it added 1, it shifted this up. It shifted the graph up. So let's see what it looks like. And yes, it did. So let's take a look at this. So if we put this value on the graph, it would be in blue. E, we said, was 2.7, and that would be about, remember, if this is 0, this is always just 1, and then it went through 2.7. If this is 2.7 to the first power, it's right about there. So what happens when we put a plus 1 in there? It shifts it up 1 unit, up the y-axis 1 unit. Now we did mention the asymptote, that for this one it would be your x-axis here. And again, by definition, as this line gets closer and closer but never reaches 0 here, that is your horizontal asymptote. Now, when we put a plus 1 in there, it shifts the asymptote up to 1 more unit, up to now a 1. And again, it never quite reaches 1. And we see that there. Okay, so this is just to give you a little visual, and we'll be able to put some of these on our graphs so you can actually have something as a reference when you compare to what they'll want in MATLAB. Now, in this case, they're asking us to look at the graph of this, where our exponent is a negative exponent. Remember, that then is just the reciprocal of what we had here. We had an example of this earlier when we talked about function of x equals, let's say, 1/4 to the x power. So it's just the reciprocal, and again, the +1 keeps it up. So let's take a look at this. Here are some points, and then there is the graph. Now, notice a couple of things here, that we get a reflection along our axis of symmetry. So what we see here then, our axis of symmetry is the y-axis, and these are reflections, and because of the +1, it shifted this up, so we have a new, as we did for this one, horizontal asymptote. This never quite reaches 1 in this case. Now, one of the things we're asked to do every once in a while, and I should mention it here, is to write the domain and write the range of these. Now, actually of both of these graphs, the range and domain will be the same. For the domain, for this one and this one, it will be from negative infinity to positive infinity, because this goes off in this direction to infinity, and so does this one eventually, and this one as well. Now, for the range, where do they start? Do they start at 1 or just beyond 1? Well, remember, they never reach the asymptote. That's its definition. It gets closer and closer, but never reaches it. So we have to put a parenthesis to indicate that 0, in this case 1. If it didn't have the 1 there, it would be 0. It doesn't reach 1, but goes to positive infinity. Okay, so hopefully you're taking some notes on this. Again, this is in the PowerPoint slides that come with your MATLAB. Now, for this case, we're asked to graph the natural log of this. And if you recall, when we were graphing logarithms, they were the inverse of what we did when it was in its regular form. So the ones we saw earlier were the regular form. This is the inverse. But before we go there, I'm wondering what's going to happen, because now we have x plus 1. The plus 1 is within a parenthesis. Before, it was outside of the parenthesis. So what will this do to the graph? Well, in general, when we have something in parentheses, and you may not be aware of this, but it's actually x minus h is the formula for this. And in order for me to get a positive 1 here, this originally had to have been x minus a minus h in there, so that the opposite of a negative made it a positive. So the rule, the shortcut rule, is whenever you see something like this, you just take the opposite sign, and where you might think it goes to the right, it's actually a negative value, so it's going to shift it to the left. It says a positive one here, then it shifts it to a negative one. Again, there's some items we hadn't covered, but just a little background. So if we plotted some points, it would look like so. And then when we did the graph, what would it do? Well, it shifts it, as we said, over 1. So now our new vertical asymptote is a negative 1, opposite sign of this. So it looks like that. And again, you're just going to be able to pick it out, possibly from a multiple choice, which is the graph of this. So take a moment to sketch this in, and we'll be doing some in our mini lectures as well. So that was our background from the PowerPoint. We're back into our mini lecture, and we're doing example 2A now. It says find each of the following to 4 decimal places. And for this, we're going to use the change of log formula, which is, if you recall, log, and this is common log of base 10 of 20 divided by log base 10 of 9. You put that in your calculator, and I'll do that right now. Now, when I put this first value into the calculator, there was a parenthesis. I had to close the parenthesis, hit the division bar, put this in, a parenthesis came up, I had to close parenthesis, enter, and then it went beyond this, but since I have to round it off to 4 decimal places, I look at the 5th place here, it's a 1, so I just drop it and don't change. Now for letter B, again, change of log formula, log base 10 of 2 over log base 10, again that comes up, it's built into the system, 15. And again you had to put a parenthesis around the 2 and a parenthesis around the 5, and the value they give that I get is this, and in this 5th place, again it's a 1, so I'm just going to drop it. If it was 5, I'd have to add 1 to the 2, and there's my answer. And again, these are actually approximate. All right. Now as we do these, you can recall a little bit the notes you had, but I will sketch them in because you are allowed to use a graphing calculator, whether you have one or not. And then particularly we want to pick out the domain and range once we do that. So again, you're not responsible to know how to do all this. You're using a graphing calculator. You just put that into your graphing calculator. What they're going to ask you is to figure out the domain and range. All right, let me set these up. And we'll do them one by one. So here we're looking for the natural log of E. Well, not the log, but it's base E. And we're shifting our horizontal asymptote down to a negative 2 right there. So in doing the domain and then later the range, this will continue on in this direction until, well, to negative infinity, and then eventually go off this direction to positive infinity. Now, the key is, as you look at this formula, this is your horizontal asymptote. So our y value here will be a negative 2 with a parenthesis, because it never reaches negative 2 and goes to positive infinity. So that's this one. Now, looking at letter B, the difference, this was a normal function where we had the graph going this way. Now in this one, we're looking at a logarithmic function. So this is going to be a graph which is the inverse. And we see that as we look at it, it's plus 1. So it's going to raise this graph up a little bit. So let me sketch that for you. So where normally this would go through the 1 here, it shifts it up 1, so it goes through the 1 there. That would be this positive 1. So what would the domain of this and the range of this be? Well, here it's approaching the y-axis, never reaches it, so this is approaching 0 and goes to positive infinity. But it's coming up for the range from negative infinity to positive infinity. All right, now let's take a look at this one. And again, studying it a little bit, it's going to be similar to this, but now we notice this is a plus 1 out of a parenthesis. This is a negative 2 within a parenthesis. And you may or may not recall that this is actually an x minus h form, where what would have been the value of that 2 in order for it to come up like this? Well, it would be x minus a positive 2, so that it would end up like this when we took away those inner parentheses. So what is happening here? Is this going to shift it to the negative or shift it to the positive when we see it in this form? And the answer is opposite sign. So we now have a new y asymptote, which will be right there at 2. And our curve will come up and go through this one here and look like so. So what's the domain? What's the range? Well, again, the domain is shifted because of this negative 2 here to a positive 2. That's the new asymptote, never reaches it, and then to infinity. And the range, again, is the same as this, from negative infinity to positive infinity. Okay, again, if you had to graph these, that would be sort of a challenge, but you want the general shape, and then what happens as we see things here. Well, for the last one, I went to my other graphing calculator, so you could see it. And I put the formula in up at the top here. And when we get the graph, this is what it looks like. So we're asked to find the domain and range. So the domain, again, our vertical asymptote is 0 here, the y-axis, so it doesn't ever reach it. So it's 0, positive infinity. And for the range, it's coming up from negative infinity, and eventually will go up here to positive infinity. So again, lots of stuff, some challenges, and as you do your practice and quiz me to earn your mastery, hopefully this will be helpful for you. Don't forget to bring your questions in, and Math Lab will help, and I will help too.